Chapter 2, Hydrology.
Let's begin with a fundamental component of life, water.
Can't get more basic than that. Okay, Brainiac, where does water come from?
Well, most people would say from the sky in the form of rain or snow or sleet. That's only part of the answer. Water can go from the sky to the earth, to underground, back up to the surface, and then back up to the sky. It's called the hydrologic or water cycle. Wetlands and watercourses play a key role in this cycle.
Bring on the experts.
Many people learn about the water cycle in grade school, and it's still pretty much true today the way that we learned it back then. That water is transported in the air, often from the oceans, where it forms clouds, and then rains down upon the earth, and then moves through the landscape in a variety of different ways.
The water cycle is such, like a day like today, it's raining, it filters through the ground and goes into the stream gradually.
Some of it infiltrates into the soil, percolates down through the soil profile, and it may immediately recharge the groundwater, recharge the aquifer, whether it's in sand and gravel or the fractures in the bedrock.
This groundwater continues to move. It doesn't just sit there. And it discharges at various points in the landscape. And many wetlands are actually discharge points where groundwater is reaching the surface and is now coming to join the surface waters and flow down to the ocean.
Of course, we have the cycle of evaporation and evapotranspiration.
Evapotranspiration, which would be the uptake of water by plant roots into the leafy matter, and you'd get transpiration, which would be a byproduct of photosynthesis.
As that water flows, it's also subject to evaporation. It may happen right here along the stream itself, or it may not happen until it reaches the ocean. And the oceans are so big that much of the moisture that we get on the land ultimately comes from those oceans. And as the water then enters the atmosphere, you begin the cycle over again.
So really it's a complete circulation of water that continually happens, especially on a day like today when it's raining out.
Wetlands and watercourses are an essential component of the water cycle. Their hydrologic functions and values can be broken down into water quantity and water quality. Let's look at water quantity first. Did you know approximately 16% of Connecticut's land area consists of inland wetlands and watercourses? One waist-deep wetland acre can store up to 1.5 million gallons of water. Our state receives approximately 48 inches of precipitation per year.
That's about 4 inches a month.
But if we get a heavy rain or a tropical storm or even a hurricane, where does all that water go? Wetlands can store a great quantity of water and then slowly release it to downstream watercourses, thus preventing floods. They also play a vital role in recharging groundwater or aquifers.
That computes. Okay, time for the professionals.
One of the obvious functions of wetlands, as you see here, is water retention. Wetlands act like a big sponge. If you've ever taken a completely dried out sponge and poured water over it, you'll see how the water just runs off the sponge. Once you wet that sponge, pour the water on it again, you'll see how that sponge holds that water. Water attracts water to itself.
The thicker and darker the surface layer of the soil, the more water it's going to hold and then slowly release after a significant storm event. So one of the functions I would expect of this wetland would be from groundwater recharge, certain times of the year where you did get a lot of water from a storm event, that it would come in here, it would soak in, it would recharge the groundwater.
If you live in a relatively urban area, it may be that the wetlands in your area are most important because of the way that they regulate runoff and the way that they detain water as it moves through the landscape and prevent flooding.
It's not a straight pipe to go from the wetlands into the stream or the river. It takes a very slow route because of the vegetation, because of all the nooks and crannies, so it slows down the water as it discharges. On a floodplain, what happens is that actually the water will leave the banks onto the floodplain, so that slows the flooding event downstream.
You can see the debris that's formed amongst the trees gives you a sense of the role that floodplain forests have in slowing water down as it moves to larger water bodies downstream. as it flows through the trees, the tree trunks themselves, the depressions around there, the microtopography, the woody debris, all has an element of roughness to the floodplain that slows water down. If that were a soccer field, the water would flow much more quickly. If that were a parking lot, even more quickly still.
When you pave an area, you sort of disrupt that function, so the water can no longer infiltrate into the ground. It's now seeing something that it's impervious. It runs off quickly to the stream. It changes the levels of the stream, and it's a real disruption to the hydrologic cycle.
Without that flood storage, water moves through the system faster with more energy, which translates into more damage.
So by moving water more slowly through the landscape, by slowing it down on the surface, by letting it infiltrate and move slowly through the soil, we're able to spread out the distribution of water throughout the season.
Now you can see how valuable wetlands and watercourses are. By storing floodwaters, they prevent costly property damage.
That is a huge economic benefit.
They also recharge groundwater, which means in times of low rainfall, our lakes and streams and even our wells won't run dry.
One small wetland won't hold a great deal of water, though.
But a series of small wetlands can hold a tremendous amount of water. Diversity in size and type of wetland are the key to a well-functioning environment.
And how do wetlands and watercourses improve water quality?
While holding the water, wetlands and watercourses allow sediment to drop out. Additionally, wetland plants and soils improve water quality by absorbing pollutants, thus making downstream waters cleaner.
Swipe to the pros.
Waters in the state of Connecticut are designated for uses such as swimming, recreation, fishing. So water quality really measures whether that water is meeting that function that's designated for it.
Water quality is dictated by how many chemicals can be in a water body before it becomes hazardous to either the aquatic life that's living in the water body or to human consumption.
Right now, we're just sitting here. We're going to take a macroinvertebrate sample, and we use macroinvertebrates as a really good indicator of how good the water quality is. The biology, the organisms living in the stream, whether it's the macroinvertebrates or the aquatic insects living on the bottom, really give us an indication of how healthy the stream is. So it integrates watershed conditions upstream. It integrates, the different water quality and pollutant levels that come down. Because if we get good critters, then we know that the water quality is good.
It's important to look at the water body and the surrounding watershed because the water body is a function of the quality of that watershed. So if you have a watershed that has high impervious cover, such as lots of pavement, buildings, then you're going to have a lot of stormwater runoff containing metals and high salt content.
So it's everything from the oil and grease that drips from people's cars. It is the zinc and copper that wears off of brake pads.
One would be solids, which tend to choke out aquatic life. They block sunlight, and that's harmful to fish and plants. High salt will have a dramatic impact on not only releasing other contaminants, but also toxicity. And then you might end up with some nutrient pollution, so excess of nitrogen or excess phosphorus can lead to eutrophication, which is excess algae growth.
In a residential or a commercial setting, people apply pesticides, herbicides, fertilizers on their lawns. All of those things get washed away when it rains.
Wetlands, again, because typically they would have more organic matter and in some cases more silt and clay and very specific kind of biological community of plants and critters, is that their ability to capture nitrogen and phosphorus is very, very efficient, very, very effective.
So as the nitrogen and phosphorus runs off the land, if it runs through a wetland, there's an opportunity for plants to take up those nutrients. There's an opportunity for the soils to treat those nutrients.
Because when you have plants taking up the nutrients through their active growing, they function as nutrient retention areas during the growing season.
A lot of wetlands, like the one that we're in here today, is kind of a depressional area on the landscape. So water is going to flow in there and kind of sit there, and then because of the vegetation and because of the microtopography, it discharges sediment as well.
People think that wetlands, just because they are touted as having this great water quality effect, can handle any problem that we throw at them. Wetlands have a capacity and they have a limit.
Wetlands and watercourses are nature's filter of pollutants and sediment. These may come from roadway runoff, agricultural practices, failing septic systems, and even emissions from factories.
That means downstream waters are cleaner for fish, wildlife, and human consumption and recreation.
And they are natural sponges that hold and slowly release floodwaters,
as well as recharging groundwater and aquifers, thus assuring an adequate and clean water supply.
Aren't wetlands and watercourses amazing?